We saw in the previous video what the SSS congruence condition was. Two triangles are congruent if the three sides of one triangle are respectively equal to the three sides of the other triangle. But what kind of problems do we come across in this category? Look at this quadrilateral with one of its diagonals drawn. It's quadrilateral ABCD. Length of AB and CD are given to us as 5 units, and BC and AD measure 8 units. Nothing else is provided. We have to prove that triangle ABC is congruent to triangle CDA. This is ABC and this is CDA. So you have been given just one figure with two triangles in it. We have to prove that they are congruent. Let's try comparing the sides of the triangles. We know that AB is equal to CD since it is given. Length of AB is equal to the length of CD. Note the order, AB and CD. These two lengths are equal. We can write BC is equal to DA as both are equal to 8 units. So two of the sides of one triangle are equal to the two of the sides of another. Is this enough to tell us that both triangles are congruent? Probably not. We need to compare the remaining side of each triangle. The third side of triangle ABC is this, and hey, the third side of triangle CDA is also this. It means the third sides of each triangle are equal. We can say that CA is equal to AC as it is the common side to both the triangles. CA is equal to AC. Since three sides of one triangle are equal to the three sides of the other triangle, we can say that triangle ABC is congruent to triangle CDA. And how did we get this? Yes, we used the SSS condition. Now here's something interesting. In this problem, we were not given two separate triangles. We kind of had to visualize the corresponding sides. Triangle ABC is upright, but triangle CDA is inverted. Some of us may find it difficult to interpret it. So to keep things simple, we can just draw the triangles separately. First, let's draw triangle ABC. This is triangle ABC. AB is 5 units long, so we write a 5 here, and BC is 8 units long, so 8 becomes the base. We just drew this triangle separately. The other triangle we are talking about is triangle CDA. Since vertex A should correspond to vertex C, let's keep the triangle like this, CDA. Length of CD is 5. Be very careful here since we have inverted the triangle. Since CD is 5, we write a 5 here. And this length is 8 units, which means that 8 becomes the base here. This is how the two separate triangles would look. We do not have information about the third side. But wait, since they are the same side, they have to be equal. There you go. We clearly see the SSS condition. This was simpler, you would think, as the triangles are placed separately next to each other. This becomes easier, yes, but it is very time-consuming. You have to practice enough problems to get used to the faster method of not redrawing the triangles. Here's one last question. In the same problem, what if you're asked to prove that angle ABC is equal or congruent to angle CDA? How do we prove that these two angles are congruent? Guess what? We can directly write angle ABC is equal to angle CDA since the two triangles are congruent. Remember, corresponding angles of congruent triangles are congruent. Angle ABC, as we can see, clearly corresponds angle CDA. Now this can be written in different ways. Some write it with the congruency sign in between. Some write it as measure of this angle equals the measure of this one. They all mean the same.